Hello class, I'm here to talk about problem 13, chapter 2. I have put here the problem. Consider the following linear program and you're maximizing and it doesn't tell you, it's just A and B or X and Y. It tells you that for, let's say, a product, A for example, you have less or equals than 5. It could be 5 hours, it could be 5 pounds. It doesn't determine. For B or Y, it's less than equals of 4. That's your second constraint. Your third constraint, you have 2 of A plus 2 of B equals 12. This is going to be make a whole lot of difference when we are solving the linear programming, okay? And all the values, they have to be higher or equals to 0. So no negative values. It's asking to show the feasible region, what are the extreme points of your feasible region, and to find the optimal solution using the graphical procedure. I'm going to try to go as fast as I can as I have recorded other videos. This is going to be assigned for your homework. So let's just begin. As usual, we always have the origin, which is 0 and 0. We start with that. Okay, what else we can see from here? It tells you that when A equals, so we don't have a B here. So A is less or equals than 5. Therefore, A value is 5, and then there is no B. Right here, I just repeated from here. We don't have a value for A, but we then therefore B is equals 4. Now we're gonna determine 2 more points. How are we gonna do that? If we do go ahead and we substitute any of these values on these equations, then we can get the other values. So for example, 2a plus 2b equals 12. Let's first use that a is going to be 5. Okay, so I'm going to substitute this a by 5. Therefore, we're going to have equals to 2 times 5, which is 10, plus 2b and equals to 12. Therefore, we're gonna subtract 10 from both sides. First, it's gonna be 2b equals to 12 minus 10, correct? B is equals to, um, oh, we already, actually, let me do it here. Sorry, so it's 2, and yeah, that's correct. And then we're gonna divide both sides by 2, so equals to 2 divided by 2. That's 1. Therefore, when A is 5, B is 1. So here we go. When A is 5, B is 1. I have one more point right there. Okay, now let's go over here and let's do the same thing for the same equation, but now we're going to be using B value when B is equals to 4. So we're going to be using the same equation as this one right here. So we're going to do 2a, but now we are going to substitute b. So equals 2 times 4 from here, b equals 4, equals 12. So 2a is equals, so subtract 8 from both sides, 12 minus 8, we got to put an equal sign, it's 4. And now we're going to divide both sides by 2. So a is equals 4 divided by 2, which is 2. Therefore, in this case, when b is equals 4, a is equals 2. And that's how we have got some more points for your graph, okay? So now I can go ahead and move this down here. That's fine. There we go. Okay, now let's go ahead and do the graph. Let's just insert a graph, just a shell. I just wanted the shell because I'm gonna put all the points individually now. Select the data, so add, so your x value, when this x value is 0, this y value is 0. That's your first one, the origin. at the second one, when this x is 5, this value is 0. Add another one. When this x is 0, y, or sorry, this value is 4, is either a or b or x or y. I just don't want to confuse you. Then we have select range. So this value is 5, then this value is 1, and one last one, when this value is 2, this value is 4, and I just showed you how to do that. Okay, and there you go, and then you have your graph. One thing, that even though you have all these points, you have to note that for these two values right here, which I believe here, 2 and 4 and 5, 1, they're not less or equal. They are not less or equals. Therefore, only what it falls into this line right here between these 2 points will be the feasible region. Okay, again, just trying to make it outline. Wait. Again, this is not less or equals to, this is not higher or equals to, so I don't have a way to shade the area above or below. Therefore, the points that the feasible region is going to consist of only the points that follow on this line right here. Okay, if you would uh, shade the other areas, what you can do, you do have other points, so you can go in insert shape. So you have that a is less or equals than 5. Here's your a, and then you have that b is less or equals than 4 right here. Okay, and then you have your origins. So if you wanted to say also that this area, you could calculate points for this area right here. This is what I was trying to do. Okay, if you would shade there this, but really the feasible region is just going to consist of this line only. Okay, so now let's go to the question. So show the feasible region. There's my feasible region right here, which is if you want to insert a text. Now let's just finish. Let me put a, there we go. So at least you know which point goes with what. Okay, this since it move. It didn't move, right? Because when I put this, it made it smaller. Okay, here we go. Okay, so and then now, what are the extreme points of the feasible region? Well, if the feasible region is just consists of these 2 points, so here are your points. Your points are 2 and 4 and 5, 1. So right here, you can do the extreme points are 5, 1 and 2, 4, or 2, 4 and 5, 1. Okay. So now you need to find the optimal solution. So if these are your feasible region extreme points, if you substitute those values over here, and you would do equals to 1 times 5 plus 2 times 1, correct? 1a, so 5, 1 times 5, right here, and then 2b, so 2 times 1 is 7. If you do the same thing for the second one, the second point, using the same equation, you're going to have 1 times 2, right here, plus 2 times 4. 2 times 4. And you would use a maximum of 10. Therefore, the optimal solution using the graphical procedure, you would be a 10, which is right here. However, if you want to use solver, I'm going to show you that it's not as difficult as it sounds. Every time I move the graph, you move the line. So let's just put solver right here. So you were trying to max. Let's just say that this it's A and this is B. Okay, and let's do it this automatic. So you're trying to figure how much you need of this, how much you need of this to maximize this equation here. Therefore, the equation is gonna be 1 times whatever from A plus whatever it's found in the equation 2 times B. Okay, and that equation is going to be subject to these values right here. Okay, so let's go ahead and let's just put my left hand side and you call it my right hand side. The right hand side is not going to change. You're just going to copy this. So 5, 4, those are your limits. And 12. This, you can just go ahead and copy your inequality signs. Right here is where we're going to do, well, it's 1A, so 1 times whatever you find for A. The second one, we only have B, so it's going to be 1 times whatever you find for B. And this is the only one that has an actual longer equation, so we're going to do 2 times whatever you find A plus 2 times whatever you find for B. Okay, now let's go to solver because all you needed really is this for solver. So let's go to data, solver, and I had worked on it before for another program, so it just stays here. So I want to set this as my objective function. I want that to show my objective or my optimal solution. I'm maximizing, okay? And we're gonna change this to cells over here. And let me delete this, and we're gonna add the constraints. Well, since they are not all the same equality or inequality sign, I cannot just put it all at the same time. So for now, I'm just gonna reference for this two because they have the same inequality sign right here, less or equals to this limit. Add, and then I want to do this equation equals to this limit. And then we're going to do OK. Leave it like this, simplex LP, make unconstrained variables, and let's solve. If solver does find a solution, do you see how it changed? There you go, 10. And remember what we said, 2 and 4 would be the best one because it yields 10. There you go, 2 of A, 4 of B is going to yield 10. Okay, let's just go ahead and do the answer and sensitivity and do OK. It's going to create some reports. And here it's going to show you again the final values 2 of A, 4 of B, that is going to give you 10. And it's going to show not binding slack and the binding ones. What does it mean? Well, if right here it says that it has to be A has to be less 2 or equals than 5, you're only using 2, so really equals 5 minus 2, that's 3, okay? And that's exactly what you saw here. And then if you do the other 2, you use all of it. See, 4, you had a limit 4, you use 4. You had a limit of 12, you use 12. And that's the answers right here. What they call this lack, what you have left over. And you would be done with problem 13. I hope this is helpful. Thank you.